Hey guys, we're going to do one last little piece of business here, and that is called modulus. Modulus, and we abbreviate that as mod. And mods are just a different way of counting, and we can have a mod to any number, but it's just a little quirky thing that math people do. So let's take a quick look at this. Charlie said, "It's Sunday today, and it'll be Sunday in 7 days." Charlie's very bright, isn't he? So what's it going to be in 770 days? Well, hopefully you notice that 770 divided by 7 is going to be an even number. So guess what? In 770 days, it's going to be Sunday again. And in 140 days, yep, still divisible by 7, it's going to be Sunday again, and so on. Allison chimes in, because Allison always has to chime in, said, and it'll be Tuesday in 2 days. Oh, I see. Well, in 2 days, so if we took 2 away from this, it'd be 70. And 70 divided by 7 is an even number, so it's going to be a Tuesday. 702 is also going to be a Tuesday. So that's kind of what a modulus is about. If we go down here, it says, if today is Sunday, what day will it be in 15 days? Well, there's 7 days in a week, so 15 divided by 2 is, divided by 7 is 2 with the remainder of 1. So it's going to be 1 day after Sunday, so in 15 days it's going to be a Monday. 26 days, well, let's see, 26 divided by 7 is going to be 3, remainder 5. So let's see, in Sunday, 1, 2, 3, 4, 5. So it's going to be a Friday in 26 days. I had to count for a minute. Did you see how I did that? If your birthday fell on a Sunday this year, what days it's going to fall on next year? Well, it's going to fall, if there's no leap year, that is. It's going to fall on a Monday. If it's autumn now, what season will it be in 100 seasons? Well, since 100, and we have 4 seasons, hopefully you knew that. 100 divided by 4 is 25, comes out evenly, so it's going to be autumn again. So you kind of get the idea about modulus. Oh, there's those lovely sounds. You missed that, don't you? Okay, so to the worksheet. Let's see. Here is 13 equals 1 in modular arithmetic. We write 13, and then notice instead of equals, we've got 3 little things going on there. 3, 1, mod 12. And that's read as 13 is congruent to 1 modulo 12. So 13 is congruent to 1 mod 12 is how we'd write that. Now don't get too confused with this. Perhaps I'm making it harder than it is, because it's really not too bad. Number 1 says, find the remainders modulo 3 of 31. Well, I'm going to take 31 divided by 3, and that's going to be 10, remainder 1. Here's the deal. I don't really care about 10. I only care about the remainder. So I'm going to say 31 is congruent to 1, and then I need to say what mod I used, modulo 3. 44 divided by 3 is 14, remainder 2. So 44 is congruent to 2 mod 3. So it's not that bad, is it? Find the remainders mod 2 of 34 minus 15. Well, 34 minus 15 is 19. Mod 2, sorry for the interruption, guys. All right, so we've got 34 minus 15 equals 9. Mod 2, well, let's see, 19 divided by 2 is 9, remainder 1. So 19 is 1 mod 2. And 141 minus 78 is 63. Mod 2, 63 divided by 2 is 31, remainder 1. So 63 is congruent to 1 mod 2. So that's how modulus work. Obviously they can get a little hairier than that, but we're not going to do that. There you go.